I thought we would talk about the digital manufacturing transformation at General Electric, some of which I'll talk about. I think that some of my colleagues in the room from automotive and other industries would sit there and go, that's not very innovative or new. But I think that we have a way to go at General Electric in order to move our whole process towards brilliant factory strategy. But I think as we were walking through the Brilliant Factory strategy and laying that out starting last year, doing some proof of concepts, and then driving that strategy broader and deeper this year, we discovered that there's actually a larger value stream even than Brilliant Factory. So I'll actually talk about how we're expanding our view on that going forward. So with that, we'll jump into it. Just first, a little bit about GE. I think everybody realizes that GE is a really big company, but a lot of people don't realize what GE does and everything that we're in. And what I've done in this slide is that I've actually kind of stripped out all the financial stuff that goes into GE. And as if you pay attention to anything going on Wall Street today, that's what we've been doing all year, is stripping out a lot of the financial vehicles within GE so that we can focus on the industrials. And our industrial portfolio, as it rolled up last year, is about $108 billion in revenue, a fairly significant portion of that. So our total revenues in 2014 were just under $150 billion. So, already 67% or so of our business was industrial based. It's just that we get a lot more publicity on Wall Street for our financial stuff, so we're trying to make that a lot simpler going forward. So we will keep some financial elements of the company together, particularly those that help finance our customers in our industrial product base. But a large scale of what's happening today, in fact, I think earlier this week, we closed out the Synchrony deal, which was our commercial and consumer financing arm for $59 billion or something like that. We're shedding those assets off so we can focus on the industrials. GE is actually, we have a footprint today of over 400 plus global factories. We operate in 128 different countries. We spend roughly $70 billion plus a year on manufacturing. So by all measures and means, there's a significant amount in the value chain and then the supply chain of GE and what we do. We also have a large number of technologists and R&D spend that goes into all of our products around this space. And we're starting to make what we call at GE a pivot, which is kind of a move towards a new model going forward. And that new model going forward is about being a digital industrial company. And that's all about leveraging the concepts of Industry 4.0, the Internet of Things, and all those concepts to drive value for not only ourselves, but our customers. So we have kind of three kind of pillars inside this space for us. We have GE for GE, which is all about our internal productivity and the way we use our technology and others' technologies to drive productivity through that. I'll get into a little bit more detail about that when we come to Brilliant Factories. And then we have GE for our customers. And for our customers, a lot of what we produce, we actually service, maintain, and optimize in the field for our customers. So it's a little bit different model than, say, automotive. When you buy a car from Ford, Chrysler, whatever, if you're like most people, you typically don't take it back to the dealership to get it serviced. When somebody buys a jet engine from GE or buys a locomotive or a power gas turbine, we're typically the ones who are servicing, monitoring, and maintaining that asset for them. Not in all cases, but in many cases. In addition, we have an ecosystem of software and technology and analytics around all of our products, whether we service them or not, that our customers use to optimize the performance of their assets. So our Internet of Things, and we like to think of it not as the Internet of Things, but the Internet of really important things, includes all of our products in the field and the data that we're pulling off of that for us and for our customers. And so our focus will be a theme around that is about collecting data on important areas of our business and our customers' business and our products and turning that data into information from which we can gather insights, and then from which we can optimize not only our performance across our entire value chain, but also our performance of our products in our field for our customers. And that's when you create a win-win situation across the entire ecosystem. Now, to be able to do that, you need a platform to make that happen. And so it so happens that over the last 5 years or so, we've built a huge software practice in which we're building a platform which we call Predix. And Predix is an industrial cloud-based engine for analytics. It's secure. We operate it in our own environment, and we do it for ourselves, so we know that it has all the security profiles and characteristics that you need and want for an industrial kind of application in the cloud. And it gives us the ability to build services, microservices, and analytics for the whole entire value stream of what we do. So it's a place for us to aggregate data in different timescales, different shapes, different sizes, structured, unstructured, and all those kinds of things, and apply analytics to it. So we're working in these 4 spaces because we think as we produce productivity for ourselves and solution and solve for our complex problems, those have a, kind of an analogous solution set for our customers, which we want to apply for them. And then we want to build it on a platform from which we can all gain value on that and create a continuous value stream throughout. And I'll talk a little bit about what we mean by that and what we call it. So our goal really is, and it's a fairly new goal for us, we just set it a few months ago, is to be about a $15 billion software company by the year 2020. That's on top of the industrial base, which we grow 5 to 7% compounded annually on the industrial side as well. So it's kind of the merging, well, it's not kind of, it really is, the merging of the physical and digital worlds together. And we see that as an enormous value proposition, not only for us and the way we operate, but for our customers as well. And that's how we start to formulate our point of view on how the industrial 4.0 or the Internet of Things comes together and creates value for ourselves and for our customers. So, but we started the journey really a couple years ago in a concept that we call the Brilliant Factory. And as most things in Industry 4.0 or the Internet, the industrial Internet it starts with your own operations, with your own factories and what you're doing there, and how you can gather more information and more insights from what you're doing. So what we discovered, or discovered is probably not a great way to say it, but what we realized is that we were investing a lot of money, effort, and time and technology in the way we design products. And that was really important because we're designing really, really complex products. A jet engine is not a simple piece of machinery. So it encompasses all the kinds of technologies around 3D modeling, finite element analysis, heat transfer, name your favorite tool. We probably use it in GE in order to create, model, and simulate our products before we ever move to prototyping and manufacture, okay? So we have a really complex 3D model of the way our products should perform, how the parts and pieces fit together, and how, more or less how we think we need to manufacture them, what the materials are that go into them. But then what we were doing, or then what we still do it in most of our factories today, we take that very complex model, that full rich representation of what our product needs to be, and we break it apart. We break it apart manually, and in many cases, we move it to 2D CAD drawings, and we move it to a set of manufacturing shop instructions that still in many of our factories today are paper-based and non-electronic, non-digital. So we lose the traceability of what we actually do and produce machine to machine, cell by cell, line by line, assembly by assembly into what that original digital intent was in the 3D model, right? And I'm sure many of you do that still today. It's a complex problem to solve. I know we've spent some time with Ford and other folks in this room understanding what they do, and we know we're not as good as they are in some of this space. So our really brilliant factory effort was started to figure out how do we get more of a digital footprint all the way through our product and manufacturing process so that it looks more like this going forward. In which case that we move from virtual product design into virtual manufacturing and simulation. How do we set up our processes, our manufacturing steps, determine manufacturability of the various products and pieces, get that pushed out into our operations so that everybody's working off the same electronic version of the truth. And then we can produce our products and get, including producing products across our supply chain, because several of, in many cases, a lot of our parts and pieces that go into our machines are produced by third parties for us as well. So we have an ecosystem around the central part, the central product as well. But then, more importantly, we can start to create the feedback loops so that we understand when we have a manufacturability issue, we can start to look at things as to when was that faulty part produced, on what shift, on what line, on what piece of machinery, under what operator, under what material set, under what BOM, routing, et cetera, all the steps that led up to that, so that we can start to troubleshoot and understand where are our real issues in manufacturing. Are they in materials? Are they in manufacturing? Are they in the operator themselves? Are they trained right? Are they operating the way we expect them to operate? Or is our design just bad? Or our manufacturability design poor? And we need to go back and redo that step going forward. So the feedback loops are what gives us a lot of information. But I'm sure, as you know, many of you I know are practitioners in this space. Going forward with this information is a lot easier than pulling it back and trying to understand the feedback loops. So we think there's a tremendous amount of value for us in how we do that, and will generate a tremendous amount of productivity in our plants through the brilliant factory initiatives that are around that. But as you started to look at the factory in and of itself, you start to think about, well, that's nice, but I'd really like to understand the customer order, you know, that went into this. What were the specs behind it? Why are we making it this way? You know, when was that order supposed to be delivered? I may ask questions of, well, don't we have this product in the field or that part in the field? Is it performing equally in the field across all the product sets that we make? So we started to think about, well, the Brilliant Factory is just an element of a bigger ecosystem that we're going to call now the digital thread. And the digital thread in its simplest form, or simplest way to think about it, is kind of the thumbprint of our product from inception to cradle to grave. You know, so understanding exactly how that product was ordered, specified, and required for collaborative design, in some cases with our customers, all the tools, processes, and technologies we use to create that design, the life cycle of the product itself, how we manufactured, engineered it, and all the steps that went into it, its quality, its inspection, all the various steps we do to ensure that it works the way we expect it to. We reassemble the information together digitally, because we've never really lost that complete thread. And then we put it in the field so our field service techs can be in front of that machine and know exactly everything that went into that product when we made it. Now you have a situation or a potential use case where I have a jet engine in the field, I have a part that has failed, the tech can stand in front of that part, type in or scan in the code, the serialization code on it, get all the information about when that part was made, what lot, what plant, what shift, what operator, understand if we have other failures of that part in the field or not, start to report back through the value chain that we're having an issue with this part. Is it wear? Is it use? Is it materials? And we can start to really investigate that and keep driving that complex problem solving back through the value chain, through the digital thread that exists as part of that product itself. We think that's the big opportunity here. It's also, quite honestly, a big, hairy problem to solve. There's lots of systems across here, as you guys all know. And there's lots of data streams that need to be collected, maintained, and stored over long periods of time. I mean, you know, a jet engine is in service for 20 plus years, basically the life of the airplane. So we have to keep that data, not only for regulation, which we have to as well, but also for performance, because we're monitoring and controlling that asset for our customer through the life cycle. So we think this is the big opportunity of this is kind of why we built Predix, because we saw that there was nothing in existence that allowed us to do this and pull this kind of information together. I'll tell you though, today, we have bits and pieces of this value stream worked out. You know, we have a very robust field services technology platform. We have some manufacturing platforms that we use. We obviously use a lot of the same platforms everybody else in the room uses around engineering and product design. But we don't have all this solved today. So this is somewhat aspirational, but the way GE moves is that we're structuring teams, organizations, investment patterns, and everything else to solve this problem now. And we will make a huge push on solving this problem next year. And we will put considerable assets, both in dollars and people and technology, in front of this problem and try to get several use cases where we can complete this entire digital thread in 2016. So it's an exciting time for us. We see huge benefits in what we're doing here. You know, again, why now, right? Why do we see this as a big opportunity for us now? You know, I think it goes back to the physical and digital worlds merging. And the Internet of Things is starting to enable to make that happen. I can put sensors on machines that I wasn't able to put on before. You know, we have, like everybody else, we have machines in our factories that are 40 plus years old, and the only cord coming out of the machine is the power cord. And we've got to figure out how to get the data off of that machine. Likewise, we're finding increasingly opportunities to put sensors on our own products to determine their performance. I think in the original days of jet engine manufacturing, I think somebody told me we might have had 50 sensors on a jet engine when we first started out. Today, there's over 5,000 sensors on a jet engine. So, you know, you start to think about the level of data and information that we're collecting. The value is in turning that data into information, into insights, and into the opportunity to optimize processes. And that's where we're working. We're working up that value chain. You know, as Dave said, I came from process manufacturing for the last almost 20 years. We had lots of data. We had very little insights and much of the data that we collected. And, you know, I think it is about finding methodologies. And I think the technology's coming into the right frame of mind as well now, where I can do analytics very rapidly. I can put them at the point of action, which is incredibly important. I can put them there in real time, so when I need to make the decision, and that gives me the opportunity to take corrective or preventative action, more importantly, preventative action on what we're doing. So that's why the time is now. You know, and I think also now today, you look at the technology stacks that are available, and I think cloud is maturing in a way that it becomes leverageable. The analytics tools are becoming simpler, easier to use, but still very robust in the ability to do complex machine learning on large data sets. The ability to manipulate data in different time scales, both structured and unstructured, gives us the opportunity to solve these bigger problems. I would say 5, 10 years ago, none of that was available to us today. So the time is coming right. The technologies are matching up with our aspirations to solve big problems, and we think it is the right time to start really pushing the envelope on what we're doing around here. The other piece too, of course, is advanced manufacturing too continues to advance. Whether it's robotics, additive manufacturing, advanced machines and tooling in our spaces, you know, these kinds of capabilities and the addition of new sensors and measurement points on these tools that we use to manufacture products intersected with the industrial internet gives us the real opportunity to do the brilliant factory kind of work as well. So the time is really right now. Now, do we have every problem solved today or every technology stack that we need? Absolutely not. And I think we're going to have to continue to, our view is we continue to watch the space and evolve. But the opportunity there is now to really create these collaborative ecosystems where we can drive value. We think the digital thread opportunity for GE is well in excess of 1% overall productivity. It's probably north of $1 billion in value across our value chain. And that's significant dollars for us. It's significant dollars we can return to our customers, significant dollars we can turn to our shareholders. And those are all very important things for our company and as we operate today. But there still continue to be challenges, right? And I probably, for those of you in the audience today, you'll look at these and you'll say, yep, check, check, check. I mean, a lot of our machine manufacturers today are not providing us with open and secure environments from which to collect data. We're still closed down and very proprietary. We need to continue to push on the industrial standards boards to create opportunities for us to open up machine information and be able to collect it in a seamless, easy way. It always pains me to see us put a bunch of sensors on the outside of the machine because the supplier won't let me get on the inside of the machine to get the data out of it. And of course, as you guys have probably, certainly fully experienced, oftentimes I have to cordon off a machine because they're running Windows XP on it, and I'm afraid that I'm going to catch a virus on it and take the machine down for the whole time. So I actually secure perimeter around the entire machine. And that also creates barriers to exchanging data and information easily. So I think as an industry, we have to continue to press and push for these standards that open but secure architectures. I'm not necessarily interested on, for instance, what drives a CNC machine and all the secret sauce inside of that. What I am really interested in is the material that's in the machine, the tooling that I'm using, the amount of pressure, the amount of turns, the amount of cycles that I need to produce a part and piece, because that's my intellectual property. That's not theirs. And that's what we're interested in finding out. And that's what unlocks value for us. The platform-based approach, like I talked before, it's all about speed at the end of the day. I'm looking for platforms that drive speed. I'm looking to easily solve complex problems quickly. And I think the better we do that, the faster we get to value. So it is all about speed. There's nice cost play there as well. The simpler we are across the ecosystem, the better we'll be. But in the end of the day, speed beats cost because speed drives value faster. And then we continue to focus, our kind of approach as we're looking at solving our big manufacturing problems is to create very targeted solutions that will solve our pain points. I think the days of us walking into a plant and saying everything's an MES solution are probably done for us. And we're going to actually target the business problems that we're trying to solve inside of there. Now, MES may be one of those solutions, but I think we're first and foremost looking to create value in the technology solutions that we're building, whether it's analytics and insights or optimizing solutions. But that's what we're trying to solve at the end of the day. And our focus areas, I'm not going to go through those. I've kind of talked through those the whole time. But I think those are kind of where areas are that we're focusing on this in order to drive value for ourselves and for our customers. So hopefully I've left you with some expanding ideas here on the way we're looking at the industrial internet and the way we're looking at Industry 4.0 from a GE perspective. We have a lot of great partners working with us on this. A big part of doing this right and laying down the right platforms is making sure we have the right infrastructure to move data and information through our systems. So we have a very strong partnership with Cisco on this and figuring out how to move data seamlessly through our factories and through our supply chain and value chain. We have partners, obviously, with other software and machine suppliers to give us the data and information that we need rather seamlessly. And these are all very important parts of our ecosystem going forward. In addition to that, we have our own software that we're using in many of our factories to drive this value. So it is about being open, getting data, turning data into information, so that we can create insights and drive optimizations, and we have to do it in a very secure way. And I think that's one of the things that we continue to stress with our teams at GE is that the industrial internet is a powerful thing. It's also a thing that can be powerfully dangerous for our people on the factory floor. So we have to do it right, and we have to do it purposefully, and we have to do it with a lot of thought. And our partners are helping us work through that, as well as our own teams. So that's kind of the way GE is looking at it. We started with Brilliant Factory. We're now at the digital thread. The Brilliant Factory is still at the center of the problem. It's the core element of the make cycle, and that's where we need to be focused on, because that's where everything eventually converges. But we also see the ecosystem for us as being even broader than that. And all the tools and techniques that are out there in the open space today are what we're interested in leveraging going forward. So with that, I think that's all I wanted to share with you guys today. I think I have maybe time for one or two questions before we move on, if anyone has anything they want to ask. Yeah.
So what is the volume of data you're looking at?
Yeah, it's a good question. It's a humongous amount of data, right? So we're heavily into additive manufacturing in GE, and I will tell you that it's a good example because it's an extreme example. One additive build for us will produce almost 1 terabyte of data in that build. So it's just one part, one build, one time. So that just gives you a scope of the maximum possibility of data. And then you have to be able to analyze that data extremely rapidly so you can give an insight back rather quickly. So that is part of the challenge across the whole ecosystem. I mean, it's hundreds, petabytes of data, that will exabytes, yeah, whatever the next biggest number is on the scale. So, yeah.
So part B of the question is vertical stage quantum computing across the
Sure. I mean, our global research center is looking at all high-performance computing capabilities. Because, right, the bigger the set of data that you're trying to do an analytic on, the harder it is to generate that. We're also looking at pre-processing of data and kind of parsing the data so that we can get to that in using machine learning so that we can get down to the insights a lot faster. And that's one way to accelerate your computational time and everything else. But yeah, absolutely. I mean, do we have a nitrogen-cooled data center somewhere? I'm sure we do. I'm not accountable for it, so I don't know. But I think that is also going to be a challenge. But the nice thing is Moore's law is still true today. So, I think we'll have a bigger problem when Moore's law stops being true.